I'm Conrad Metcalf with the New York Building Performance Contractors Association. This is a 20-year-old nonprofit trade association that has been working for all these years to build a viable market for energy efficiency services. I want to welcome you to this first webinar in our second series to promote the practical deployment of air source heat pumps across New York State. The goal of this series, I might mention, is primarily to bring new entrants into the industry, and also to ensure that existing HVAC contractors understand not only the implications of electrification, which is essentially the transition from fossil fuels to renewable resources, but also the criticality of installation details, because we don't want the same thing that happened to windmills in the 70s. We don't want to happen to air source heat pumps. We want to ensure that this transition will be successful. For those of you who weren't around in the 70s, we kind of jumped the gun on windmills in the 70s, and the ones that were installed weren't that successful. And that kind of gave the whole thing a bad name. We don't want that to happen to heat pumps, and especially air source heat pumps. Cold climate air source heat pumps have a lot of potential, and we want to make sure that we get them started off right. So this effort, this series of webinars started last year with a group of inspections. Tatum Engineering did inspecting air source heat pump installations, and from the data that was generated, we identified some patterns that were evolving and that evolved into this training. And we hope that we can help contractors who are doing installations to avoid common installation problems. We also hope through this effort to attract new workers to this industry by simplifying the path and by clarifying those aspects which are not so simple. So that's the series here in a nutshell. And while we're on that subject, I'd like to take a moment to thank our sponsor for this webinar, HeatSmart Tompkins. Brian Eden heads up HeatSmart Tompkins, and I have nothing but praise for the work he's been doing. I'd also like to introduce our instructor, John Herod. John is the founder and the co-owner of Snug Planet, a full-service contractor based here in Ithaca, New York, doing heat pumps and energy efficiency services. And so John is waiting in the wings here, but first I just wanted to quickly mention that we will be taking the time to answer all your questions as submitted through the QA function. We'll answer these questions towards the end of the webinar, but you can also feel free to ask your questions at any time. As usual, there'll be opportunities to share your thoughts in the chat window. I strongly encourage you to do that. And I also want to encourage you to complete both the pre-survey, the pre-webinar survey, and also the post-webinar survey afterwards. These are very quick, very easy. We'll send out links to the documents that John talks about to those of you who submit these surveys, so you don't want to miss that. And so now I'm just going to hand control over to John. And John, I can tell you're there. Are you ready?
I'm ready.
Okay, very good. Thanks for being here. Thanks for everybody to be here. And John, take it from there.
Yeah, thanks, Conrad, and thanks so much, everyone, for attending today. Today, we're going to be talking about why every home will need a heat pump. And I hope you'll catch some of the reasons that we're so enthusiastic about these. And if this is an area that you're considering going into, I hope you'll start to see the potential, not just as a business opportunity, but an opportunity to do some real good in the world. Just to tell you a little bit about me, I originally went to school as a field biologist, and then in 2000, out of concern for climate change, I made the jump into energy efficiency and home performance. I started out as an energy auditor and envelope contractor, did a lot of energy audits, a lot of blower door tests, a lot of loose filling attics with cellulose and encapsulating crawl spaces. And eventually this led me into the field of deep energy retrofits. These are very comprehensive projects, the kind of thing where you take all the siding off the house, replace the windows, clad the entire house in foam, and then put the siding back on. And we wanted to see how far we could go to reduce a home's emissions through this envelope-based approach. And what we found is that when we did all this, and sometimes these projects would end up costing, $80,000 or $100,000, we did a pilot project funded by NYSERDA, that after all this work, we were only able to cut a home's carbon emissions by 70%. A sizable reduction, but not enough to achieve our climate goals. And the expense was way too high to make it into something that could be scaled. And this got me thinking about electrification and alternate paths to reducing homes' carbon emissions. And this really got me on the path towards learning more about heat pumps. So over the last 5 years, my company, Snug Planet, has installed well over 100 heat pumps in the Ithaca area. And I'm also, as I'm learning more about this, moving into doing more writing. As when I send out the slides for this webinar, I'll also share a couple articles that I wrote for Building Performance Journal that share some more insights into heat pumps. So this talk today is really targeted at people that have an entry-level knowledge of heat pumps, that are considering moving into this industry from a business perspective or as part of a career change. We want you by the end of this to be able to articulate the benefits of cold climate heat pumps, how they relate to New York State's larger goals for decarbonization and clean energy, to talk about some of the benefits that heat pumps offer to homeowners, the incentives that are currently being offered by utilities and by NYSERDA itself, which are very rich and have the potential to make these systems accessible to people across the economic spectrum. And then to look at some scenarios where heat pumps are really no-brainers that make a ton of sense. One of the things that has really attracted me to cold climate heat pumps is the fact that they solve multiple problems at once. They help us decarbonize our energy system and cut our emissions, but they also help with energy affordability and poverty reduction. They offer the opportunity to improve the comfort and the health of New Yorkers. And I hope you'll see that this can also represent a tremendous business opportunity, whether you already have an existing contracting business or you're looking to start a career in this area. That there's tremendous opportunities here. So just to give a little bit of the big picture of why we're doing this and why it's become such a priority for New York State. This graph shows carbon dioxide concentrations over the last 10,000 years. These have been reconstructed from ice cores in Antarctica and more recently from direct observations at an observatory in Hawaii. And what we see is that beginning in the at the time of the Industrial Revolution, carbon dioxide concentrations start to increase very rapidly. This chart only goes through the year 2000, but if you continued it out through today, you'd see that concentrations have risen from, starting point well below 300 parts per million to well over 400 parts per million. So they're literally off the chart. What's driving these increases? This graph shows the adoption of different fuels over time. And we can see in the early Industrial Revolution, coal was one of the first fossil fuels that came into widespread use. Beginning in the late 1800s, petroleum, and then natural gas. So each of these fossil fuels has increased steadily. Interestingly, this growth has occurred simultaneous to a huge growth in our economy. But over the last couple decades, economic growth has really outstripped the increase in fossil fuels. So we're starting to see a decoupling. We're starting to see that you can increase economic growth and well-being without increasing fossil fuels. And as renewable fuels become a larger and larger part of this mix, I think we'll see further decoupling of that. So one of the big consequences of this increase in carbon dioxide has been an increase in global temperatures. Right now, we're around 1 degree Fahrenheit above pre-industrial levels, and you can already see some of the disruption that's creating in terms of droughts, wildfires, flooding in different parts of the world. And so if we don't address this and do it soon, we're going to keep climbing, and the disruption's only going to get worse from here. New York State has really taken leadership among the states in terms of developing a plan to address climate change. And the big part of this is what's called the CLCPA, the Climate Leadership and Community Protection Act, which is a really ambitious 30-year plan to get New York State off of fossil fuels. We are in the very early stages of that, and one of the big objectives at this point is to start growing our clean energy workforce so that we have the capacity to handle some of these very ambitious goals. We're going to be implementing a lot more renewable energy, distributed solar, rooftop, and solar farms. We're going to be upgrading the grid to incorporate more storage so that we can handle some of these intermittent energy sources. We're going to be ramping up offshore wind. And between these things, by 2040, we should be close to 100% clean electricity. So at that point, our electricity grid will be zero carbon, and any usage that we can move from fossil fuels to electricity will also be zero carbon. And the end goal of this is by 2050 to achieve an 85% reduction in greenhouse gas emissions relative to 1990 levels. I'd like to see us go closer to 100%, but hey, let's see what we can do. Where do buildings fit into this picture? The dark blue slice of this graph shows the portion of New York State's emissions that are related to energy. And of that, about 30%, actually 30% of this whole graph is from on-site combustion of fossil fuels in buildings, mainly for heating, but to a lesser extent for domestic hot water. And this is the portion of this that we're going to be going after when we talk about electrifying our building stock and installing heat pumps. So what we've really outlined, and there's been a lot of people that have contributed to this. One of the kind of landmark articles in this is an article that appeared in Vox a couple of years back called "Electrify Everything," that really outlined a path to get from where we are today towards zero emissions across the board. In housing, what that means is that what we want to do is increase efficiency through insulation, air sealing, appliance upgrades, lighting upgrades. The remaining fossil fuel use, we want to replace those furnaces, boilers, water heaters, cook stoves, replace those with electric equipment. And at the same time, transition our grid to 100% renewable. So this is, presented here as kind of a stepwise pathway, but really all these tracks can be pursued in parallel, and together we will get from where we are to a zero emissions housing stock. In addition to the emissions reductions, there are some real benefits, particularly for people that are in the low to moderate income brackets. In upstate New York, we have a lot of people that are heating with very expensive delivered fuels, oil, propane, kerosene. And we also have a fair amount of houses that are still heating with electric baseboard or electric space heaters. Some of these are, as in the picture on the top, multifamily housing, in this case, a complex designed for low-income seniors. But then we also have a lot of our rural housing stock, whether it's mobile homes, old farmhouses, et cetera, that are relying on some combination of electric resistance heat and oil and propane. And their electric bills and their energy bills can be quite high. Air source heat pumps represent an opportunity to greatly reduce their heating costs and essentially reduce that energy burden that can take a big chunk out of their monthly paycheck. Air source heat pumps are even lower in cost to operate compared to natural gas furnaces. So it's a great opportunity to take much of this housing stock that doesn't have access to natural gas and give them a low cost way to heat their homes. Heat pumps also give us an opportunity to address a lot of comfort and air quality problems that we run into in our housing stock. You know, it's very common to run into houses that have either poorly designed or poorly maintained distribution systems. So you have rooms where, you know, for whatever reason, the ductwork has gotten damaged or disconnected. You don't have good distribution to a particular room. It's very common to see things like bonus rooms and additions that never got adequate heat because the ductwork to them was just never properly designed or installed. You know, developers will call this room here over the garage, they'll call that the bonus room. In our energy efficiency world, we sometimes call that the frog, the freezing room over the garage. It's far from the furnace or the central system, and it's often very difficult to properly heat and cool. Air source heat pumps give a great opportunity to address some of those comfort problems in a targeted way, and also to give homes very high quality air conditioning, a big upgrade versus your window air conditioner. We can also address some of the air quality problems that are associated with older fossil fuel based heating systems. You know, poorly maintained flues, blocked flues, and houses where you have pressure problems in the house, you can get carbon monoxide spilling back into the living space. And, you know, that can cause either, you know, in some rare cases, fatal consequences, but also just unpleasant symptoms. It's turning out that we're finding out that gas cook stoves, even if they're not producing large amounts of carbon monoxide, are a big impact on your indoor air quality and can lead to asthma and other issues like that. So by getting all those fossil fuel burning appliances out of the house, you have an opportunity to eliminate those combustion byproducts. In some houses, we have ductwork that's passing through spaces like attics where they're picking up you know, pollutants like insulation particles, dust, mold spores. We can address those problems. We can also bring better dehumidification into homes. It's turning out that, you know, kind of the three pillars of maintaining indoor air quality with HVAC are dehumidification, filtration, and outdoor air ventilation. We have big parts of the year where it's humid in houses, and by controlling humidity, we can reduce the growth of mold spores and other biological contaminants. We can also think about ways to add filtration and outdoor air ventilation. These are things that are good for indoor air quality under any circumstances, but in this age of COVID have acquired kind of new significance. To talk a little bit about what this translates into as a market opportunity. Right now, we have about 34% of households in New York that are heating with oil, propane, or electric resistance. So that's almost 2 million households that are great candidates from a strictly cost savings perspective for installing air source heat pumps. We have 48% of our houses that cool with window units and 15% that have no air conditioning at all. Again, people that could benefit tremendously from heat pumps. And because all this equipment turns over every 15 to 20 years, we have a lot of this that's going to require replacement in the next decade or decade and a half. And if folks replace their existing fossil fuel systems with new fossil fuel systems, they're going to be locked into those for another 15, 20 years. So we have this window of opportunity each time one of these things turns over to transfer people over to all electric. There are generous incentives available statewide, and I'm going to go into those in a little more detail, but essentially there are thousands of dollars available for every household that can bring down the cost of these projects and make larger work scopes, more ambitious work scopes possible. There are heat pumps that will work in just about every residential application. For space heating and cooling, we have air source heat pumps, which I'm going to focus on today. I'm going to touch briefly on ground source heat pumps. And for domestic hot water, we have heat pump water heaters, which are a fantastic product and kind of the gateway for a lot of people to getting away from fossil fuels. This is a drawing that I like that was produced by our local Cornell Cooperative Extension that explains in a very general way the way that a cold climate heat pump works. You have a refrigerant, which is a gas that can absorb heat and then release it depending on whether it's evaporating or condensing. And in the wintertime, the low pressure side of the system outside absorbs heat even from very cold air. That refrigerant then moves through the compressor squeezes it, it raises its temperature, and now that heat that's been absorbed from the cold outdoors is now at a temperature at which it can be released to the indoors. And then the cycle repeats itself. With these systems, you are typically bringing 3 units of heat into the house for every unit of electricity that you use. So they're roughly 3 times more efficient than electric resistance heat. In the winter time, that's how it works. In the summertime, this process reverses itself, and now you're absorbing heat inside the house and releasing it outdoors. One of the most common types of air source heat pumps is what's called a mini split. This has an outdoor unit where there's the compressor, the outdoor coil, and a fan. It's connected to an indoor unit, a ductless head, that also has a fan in it and a heat exchange coil, and that either absorbs or releases heat depending on whether it's in cooling or heating mode. The components of these systems are the outdoor unit, the piping and wiring that connect them, the indoor unit, and the controls. These are a couple examples of typical outdoor units. The ones with the single fans can provide up to about 30,000 BTUs, so enough for either a portion of a house or a small, well-insulated house. And the larger ones, the dual fan units, can provide upwards of 50,000 BTUs. And so this provides enough heat for most of the housing stock that we're working with in our area. Common indoor units in the ductless category are ones like this high wall unit on the right. These are probably the most popular. Usually there's wall space high on the wall where there's some available real estate that can be used. But there are also low wall units like this one that provide a little more traditional appearance. In our climate, because we do a lot more heating than cooling, it's actually ideal to release the heat a little bit lower in the room. But there are also a lot more options available. In addition to the high wall units that you see, there are what are called ceiling cassettes that can be recessed up into a ceiling so you don't have to give up any wall space. There are picture frame units where the fans and the heat exchangers are hidden behind a picture frame that can hold any artwork or photograph that you like. There are what you see in the middle and the lower middle, what are called compact ducted units. These are flat, wide little blower coils that can heat either a suite of rooms or in some cases an entire house with a compact network of ductwork. And then on the lower left, you see what I think has probably the highest market potential, the fully ducted air handler that can be swapped out directly for a gas, oil, or propane furnace. A lot of people have negative associations with heat pumps, and a lot of these are from older generation of heat pumps that was a lot more common down in the South and in the Mid-Atlantic than they are up here in the North. A lot of the associations people have are that these systems are loud, that they don't work well at low temperatures, and that you end up relying a lot on the backup electric resistance heat, which drives your costs through the roof. Modern cold climate heat pumps have really solved these problems. This is a graph that shows performance of a standard heat pump, that older generation of heat pump that I was talking about with the gray line. You can see that its performance really decreases as you get down into the lower temperatures. And when you need it most, its output essentially drops to well below what you need. Modern cold climate heat pumps take advantage of a number of features, very sophisticated electronics, variable speed compressors, larger heat exchangers, and control algorithms that really allow them to extract heat down to well below 0 degrees Fahrenheit. The cold climate heat pumps that we're talking about maintain close to their full output down to about 5 degrees Fahrenheit and still are producing useful heat at well below 0. So these are units that are really designed to operate, even in the coldest conditions that we're going to experience around here, and to rely on backup heat very little, if at all. Another technology that I wanted to mention, because it will come up, although I think it's kind of a transitional technology that is going to be going away in the future, and NYSERDA isn't really putting a lot of backing into it, but I think it's important to know that it's out there, is what we call hybrid heat pumps. These are essentially comparable to those older generation of heat pumps that I mentioned. They have fixed speed compressors, and they connect to a coil that sits on top of an existing oil, gas, or propane furnace. And these provide cooling like an air conditioner. They provide heat down to somewhere between 30 and 40 degrees. So they can carry you through big chunks of the heating season. But when the temperatures start to drop below that, they switch off and the system switches over to the fossil fuel-based heating system. These, I think, had their place, but I think with the modern cold climate heat pumps, these are largely becoming obsolete. There are cases where they may make sense, where for whatever reason people don't want to convert entirely to heat pumps, or where the output of a heat pump just can't meet the needs of a larger or leakier house. This is an example of a hybrid heat pump. You've got your outdoor unit up on stilts to keep it up above snow depth. You've got a gas furnace with the heat pump coil sitting on top of that, and the refrigerant lines connecting to the outdoor unit. Okay, so that's air source heat pumps. I'm going to talk briefly about heat pump water heaters. I love this technology. I mean, we install several of these a week, and people seem to really like them too. These are essentially a storage tank on top of which is mounted a small heat pump that extracts heat from the basement and deposits it into the tank. And so during times of the year when you're not doing any heating, these are incredibly cost effective, and in some cases well over 3 times more efficient than electric hot water heaters. During the heating season, they do steal a little bit of heat from the basement, so they may end up dropping the basement temperature a couple degrees, which has to be made up by your central heating system. This shows what goes on inside one of these. The air from the basement is moved across the heat pump evaporator coil by a fan. The heat is captured and deposited in the tank. These tanks typically have electric elements inside them that can be used during periods of high demand. So if you've got, guests, you've got, a family that's taking a lot of showers in quick succession, the electric elements will kick in to make sure that you've got enough hot water. And these are all electric. They use the same circuitry as an electric hot water heater. So that's a very easy switch out. But we're also finding increasingly that we're using these to replace fossil fuel-based water heaters, even in natural gas homes that have natural gas. I'm not going to go very deep into geothermal. It is a wonderful technology that's worthy of hours of webinars all to itself. Essentially, instead of exchanging heat with the outdoor air, you're exchanging heat with the ground. And in that way, you're taking advantage of the fact that compared to outdoor air temperatures, which might vary down to 0 or below in the wintertime, you're taking advantage of the fact that the temperatures in the earth are a lot more stable. And so you're able to gain efficiency because rather than trying to extract heat from 0-degree outdoor air, you might be extracting heat from 30 or 40-degree ground. You can see that ground source heat pumps typically are a little higher in efficiency than air source heat pumps. And their efficiency drops less as you get into the colder temperatures. Another thing that is a real argument in their favor is that they have a long system lifetime. The tubing that's buried in the ground has a life expectancy of 50+ years. And because all your moving parts are inside the house, they're protected from the elements as well. So these are very efficient, very long-lived systems. They also are the most expensive of the options available. Depending on how it's set up, it can either provide space heating only, either as forced air or as in-floor radiant, in some cases baseboard heat. It can also be set up to include domestic hot water, also produced by the same system. Just to give you a sense of what the footprint of one of these loop fields looks like, if you go with the horizontal loop field, which is generally the more affordable option if you have the land and the open space, you might be looking at a footprint of, roughly, for a typical system, something like 33 feet by 250 feet. This photo was provided to me, and I think it was from a more southerly climate, because these trenches only look a couple feet deep. We're typically burying our loops at least 4 feet down. If you want to minimize the amount of ground disturbance, or you just have a small footprint to work with, you can go with a vertical loop field. And in that case, you have to bring in a drilling rig. This tends to be a more expensive option, but you can get your entire loop field installed vertically in a much smaller footprint. So as we look at, kind of the benefits to heat pump technology as, to our society at large, we can see that there's benefits to air quality. Not only are we eliminating combustion inside the home, but we're eliminating the emissions from, the flues from oil furnaces and boilers. We're not producing carbon dioxide. we're adding very high efficiency cooling to our housing stock. And one of the reasons this is important is that during those hot afternoons in summer, a lot of stress occurs on our grid. And that's when all those air conditioners kick on around the state. By adding efficient cooling, replacing the older window air conditioners, older central air conditioners, we're reducing that stress on the grid and saving utility expenditures. And similarly, we're reducing the amount of costs that utilities are going to be spending on natural gas infrastructure, costs that ultimately get passed on to ratepayers. I think, especially as we're thinking about the economic disruption that's happened due to COVID, this point of reducing the energy burden on the lowest income households becomes an important point in terms of our benefits to our society and social justice and poverty alleviation. So I think it's something that's well worth considering. And NYSERDA has recently launched some very ambitious programs to help bring this technology to lower income households. There's the potential here to support local living wage jobs. As we transition away from fossil fuels, there's going to be disruptions in those industries. There's an opportunity here to create good living wage clean energy jobs right here in New York State, and in the process support the larger process of decarbonization. When we look at selling points, reasons why homeowners might want to invest in this technology, for one, it reduces their heating and cooling bills. It can be a great fix for comfort issues, as we discussed, the freezing room over the garage, or the addition that never quite gets warm. We can avoid all the hassle and noise associated with window air conditioners. We can eliminate carbon monoxide and other combustion byproducts from the house. And we have a lot of options to fit these devices right into the decor of the house. Some of the places where the air source technology really shines, one is houses that have open floor plans. Oftentimes we'll see houses that have, either the entire first floor on an open floor plan, kitchen, living room, dining room, all quite open to each other, or a ranch style house where you might have those same rooms all together on one end of the house and bedrooms on the other end. A single ductless heat pump can oftentimes provide heating and cooling to that entire section of the house. These are also a great retrofit for houses that have electric baseboard. These folks have high energy bills to start out with, and you don't necessarily have to replace every electric baseboard in the house. If you put a ductless heat pump in an area where you have an open floor plan, you can still use the electric baseboard for the small rooms, but you can let the heat pump do the heavy lifting and, in some cases, cut your electric bills by half or more. The box swap scenario, what I'm talking about there is a heat pump that swaps out for an existing forced air furnace. I think that's the retrofit that really has the greatest potential to scale. We have upwards of 80% of the housing stock in many areas has forced air, and many of those can be accommodated with modern cold climate heat pumps. And so I think, this is probably what's going to be the thing that allows this technology to really scale up around the state. On the other end of the spectrum, we see that we're installing a lot of these for customers with wood stoves. Oftentimes, folks were very excited about heating with wood early on, and 10, 20 years in, their backs are sore, and they want to be able to go away for a couple weeks. And so in the middle of wintertime. And so we are finding that we're actually installing a lot of these as backup and supplemental heat or as primary heat in houses that were previously heated by a wood stove. Folks will oftentimes want to hang on to their wood stove in case there's a power outage, but it means that they're not reliant on going out to the wood stack every day. We're also finding that these are a great retrofit for houses that have older steam systems. Steam systems can be very expensive to replace and retrofit, and oftentimes the disruption of tearing out the old radiators and running new piping around the house makes it prohibitive. So we can sometimes instead take them from steam technology, 1880s technology, to modern cold climate heat pumps, and kind of leapfrog the whole 20th century. This is an example of the kind of box swap I was talking about. This is a cold climate central ducted heat pump replacing a propane furnace, and it heats an entire, it's about a 1,500 square foot ranch house. When we start talking about these with homeowners, we can talk about what we in our company call the green lights. These are the things that when these topics come up in the customer interview, you know that you're very likely to get good traction in the sales process. That these are people that are interested in engaging around heat pumps because it offers such clear benefits to them. One is, as we mentioned, the people that are on the expensive fuels, the delivered fuels, and the electric resistance. Homes that have older equipment that is coming up for that replacement, because in that case, they're looking at spending a bunch of money on their heating system anyway. With the incentives that are in place, it is oftentimes cheaper to install a high efficiency cold climate heat pump than it would be to install a natural gas furnace plus conventional air conditioner. People that want to add cooling. This is a place where cold climate heat pumps and ductless heat pumps in general really shine. And I think with, a lot of people spent their entire summer at home, working from home, and are realizing that, hey, it would be really nice to have some decent cooling. So at least I'm comfortable when I'm sitting through 25 hours of Zoom meetings. And another, really strong market is the environmentally conscious customer, the person that, might be driving an electric vehicle. They might be active in anti-fracking or anti-pipeline campaigns, and they want to walk the walk. And I think this is this has been a tremendous market for our company. I don't want to focus on it entirely because I think the benefits of heat pumps apply across the board, regardless of your environmental stance and your political beliefs. But it is oftentimes a place where people can find that their actions can align with their values. New York State is offering fantastic incentives and financing, and these remove some of the big barriers, so that the barrier of cost and resources to installing these systems. I did want to mention the importance of having an energy audit or some kind of similar assessment as part of this process. In order to get these systems right, we really have to know how many BTUs are needed. And if we can get that dialed in, not only can we design a system that operates efficiently and does the job, but also reduce the cost to the homeowner because we're not putting in something bigger than we actually need. Two things that really help with getting those calculations dialed in. One is the use of the infrared scanner. This allows us to quickly assess whether the house, the walls, and the attic and spaces that we can't look at directly, whether those are well insulated. And then the other is the blower door, which is the device you see set up here. Essentially, it's a big calibrated fan We hook it up in the one of the entry doors of the house, and we use it to measure the house's air leakage. And sometimes we can pinpoint areas where some air sealing can yield some really great benefits. But we can also put that number into our sizing software, and that can tell us, if there's one variable that affects how much heat you need, it's how leaky your house is. As part of this process, we may be able to prescribe some relatively simple improvements to the building envelope. Usually these include insulating and air sealing the attic, insulating the basement, crawl space, rim joists. This energy audit is also a great opportunity to engage the homeowner, familiarize them with the heat pump technology, discuss the benefits, and present to them the rebates and incentives. It's one of the things I like about the energy audit process is it's not just a sales. It's a opportunity for customer engagement, for collaborative problem solving, and done correctly can lead to a very high conversion rate. New York State is offering some really fantastic incentives right now. The utility incentives through National Grid or NYSEG or RG&E or whatever your local utility is are for air source heat pumps, $500 per outdoor unit for partial load systems, ones that aren't designed to meet the full load of the house, but $1,000 per 10,000 BTUs for systems that meet the full load of the house. So it's not unusual for us to see, $3,000 to $5,000 worth of incentives for typical houses. They're a little bit more for ground source heat pumps, reflecting their higher efficiency. And there's also $700 available towards a heat pump water heater, which can take a big chunk out of the price. So these utility incentives can be combined with NYSERDA programs, including the Assisted Home Performance, which is their low income or their low to moderate income matching grant program. And that can provide a 50% cost share up to $5,000. Until the end of the year, that has been extended to households that are up to 120% of the area median income. So roughly 70% of households are going to be eligible for this enhanced grant through the end of the year. There's also financing available so that people can spread the costs out over a 15-year period. Oftentimes, with that in place, they can save significantly more in energy than they're spending on loan payments. And just recently rolled out, and I didn't have the time to turn this into a slide. I still need to kind of get my head around some of the finer points of this, is that NYSERDA is offering a program that allows the households eligible for Empower, which is typically the lowest income bracket, 60% of median income or below, to find ways to provide 100% of the cost of heat pumps to those households. This is only for households that are not on natural gas, which makes sense economically. But I think this has potential to do, a tremendous amount of good for folks that have a, very high energy burden. I wanted to do a quick case study here. This is a project that we worked on, and these were the incentives at the time. They've since changed. They've actually since gotten a little bit better. But this was a simple little 2-bedroom ranch, and we replaced the old oil boiler with an indirect, the oil boiler had an indirect tank for its hot water. And we replaced that with a 3-head air source heat pump, 1 head in the open floor plan, and 1 head in each of the 2 bedrooms. And we put in a heat pump water heater. So we met all the heating, cooling, and hot water needs of the house. The total cost of this project, the full cost was over $15,000. But after the NYSEG rebates, for the heat pump and the water heater were taken off, the assisted home performance grant, some grants that were offered by our local HeatSmart Communities program. That brought that cost down to under $5,000. The customer financed that over 15 years, so their monthly payment was only $34 a month. When you took their, and we actually did the actual pre and post energy costs on this, they were saving over $60 a month on oil, even when the increased electric use was taken into account. So if you net out the increased electric use and the loan payments, they're still coming out $30 a month, almost $30 a month ahead of where they were. These systems also have a lot of potential in commercial buildings. There are some advantages that really apply there. One is that they do provide very high quality, quiet cooling. And when you have a space where you have people and activities that have different temperature requirements, you can have finer grained control compared to a central ducted system. So you can have one office where a person keeps it a little warmer or cooler, and they'll have control of that. If you have a space that is subdivided and you want to be able to build the tenants separately, it's a lot easier to do that compared to some central systems that are out there. When you do move into the commercial space, it becomes a business decision as opposed to a personal decision, and so you have to be very ready to talk about payback and return on investment. But I think it's also worth mentioning that the biggest expenses in almost any business are employees, and keeping them happy and productive offers tremendous benefits. So to meet New York State's energy goals in terms of scaling up heat pumps, we are going to need to be installing roughly 700 heat pumps a day, 7 days a week, 365 days a year. We don't have the labor force to do that now, and we are trying to figure out how we can scale that labor force dramatically. And that's part of what this training series is about. Nationwide, there is a huge shortage of HVAC technicians. There's something like, last numbers I read were on the order of 100,000 positions that could be filled today if we had the skilled people. So I just wanted to mention some of the entry points that are available for people to get into this line of work. If you are an existing envelope contractor, then you already have a whole house mindset and you have some familiarity with energy modeling, and you probably also have some basic electrical and carpentry experience. So making the jump to cold climate heat pumps is definitely doable. If you're a mechanical contractor, you probably already have most of the skills required, plus business systems that are geared around recurrent service and on call for emergency situations. But another kind of whole group of people that I hope will get interested in this are folks that are either recent high school or college grads, or mid-career people that are looking for something new that offers a lot of benefits to society, and also the opportunity for good living wage jobs. And there's opportunities here in the sales, in the design, in the installation and service side of things. If you've had some formal or informal experience in the building trades, whether it's actually working a construction job, or helping a family member or friend remodel, or even volunteering on a Habitat for Humanity project, that gives you a good head start. And then the other things that I think are important criteria are some interest in green technology, and some mechanical aptitude, some comfort working with your hands, and working under different temperature conditions, attics, crawl spaces, and things like that. It is so important, as Conrad mentioned. If we want this to go well, we need to make sure that these systems are designed and installed properly. And the third webinar in this series is going to really drill into a lot of the learnings, sometimes the painful learnings that I've made in the course of getting into this, to help make sure that future installations go really well from the start. We're going to talk about designing and sizing the systems to match the house. How do we integrate these with existing systems? What are the best practices as far as installation and commissioning? How can we educate consumers to use these systems properly? And then what kind of maintenance do we need to do to make sure that these systems last a long time and perform well over their lifespan? Design considerations include, what are our goals with this system? Do we want to try and just serve one part of the house? Do we want to just try and meet part of the load during the shoulder seasons, or do we want to design a whole house solution that meets the full load of the house? What goes into the sizing calculations? What are some of the design options in terms of using ductless heads or a ducted system, or maybe some combination of those two? What are some of the best practices for equipment placement, equipment selection, duct design? And then what thermostats and other controls can really help these systems provide the, kind of the maximum level of comfort. When we talk about installation and commissioning, we're going to look at details of where to locate the systems, how to do the refrigerant piping properly so that it doesn't leak, how to do the electrical systems, what are some of the criteria there as far as best practices. And then a big part where I think there's huge opportunities to raise our game as an industry are in better testing and commissioning of these systems. Testing the lines for leakage, making sure that when we get the system ready to put the refrigerant charge in, that we've removed all the air and moisture from the system. And then going through the startup process so that we know that when we roll out, the system's really working the way it should. And then longer term, we need to think about how do we keep these systems operating well over the long term. And a lot of that is customer education, making sure that people know what maintenance they need to do on their own and when they need to call us. Making sure that we have a plan for preventive maintenance and keeping these systems clean and checking their operation. And then, building up our capacity as an industry to troubleshoot these systems and get them repaired and working properly as quickly as possible. The next webinar in this series is going to be a week from today, same time. And we're going to go a little bit more into the business opportunity and what it would look like for you as an existing contractor or a person looking to change careers to move into air source heat pumps as part of your line of work. And then the following week is going to be the most technical of the 3 webinars. And this is really intended for folks that are going to be designing, installing, and quality checking these systems. It's going to be based in large part around an article called Cold Climate Heat Pumps Do's and Don'ts that I wrote for Building Performance Journal, which you'll be getting a copy of. But that's going to be one, if you're interested in digging into the technical stuff, that's going to be the one to attend. And then what I'm really excited about is on November 7th in Ithaca, we are going to be doing a hands-on training. We did one of these back in August, and it went really well. We got a group of, there were about 10 people, brought them up to our shop here in Ithaca, and we installed a ductless system, soup to nuts, in a single day. And people got to see the got to see the project from start to finish. This next one, the one that we're doing on November 7th, we are going to be doing the same thing at a Habitat for Humanity new build that's going on here in Ithaca. And so we made it a little bit longer because we ran a little bit over last time. It's a 7.5-hour day, but in the process, you'll get to see the entire installation of a cold climate heat pump. You get to do hands-on just about every step of the way. So we are going to limit the registration for that so that everyone can get a good hands-on experience. So if you're interested in that, please register as soon as possible. And with that, I'm going to open it up to questions. Thank you very much.
Very good, John. Thanks very much for being there. We do have a bunch of questions, and I'll just start throwing them at you. The typical lifespan of an air source heat pump when compared to a boiler, how does that play out?
Yeah, so the older generation of cast iron boilers were very long lived. You were looking at 250, 300 pounds of iron and very few moving parts. And so many of those lasted 30, 40 years or more. I don't think you're going to see that same life expectancy out of modern condensing boilers. Those are probably something in the 20 to 25 year range. A lot of that depends on maintenance and on water quality. What we've been using in our projections for air source heat pumps are a lifespan of 15 to 17 years. And I think that's totally achievable with proper installation and maintenance.
Very good. One of our attendees noted that some of his competitors are not as focused on energy efficiency. They're installing larger systems like 50,000 BTUs to like 100,000 BTUs, even for small homes with a load of maybe 35,000 BTUs. Is there any way we can influence this system or this process so that we don't dry up all the funds before they are, before they should be dried up, so to speak?
Yeah, so the utility incentives are, the rules the way they're written are that you are supposed to do a proper sizing calculation, an ACCA Manual J, and that they will only provide those incentives to systems that are designed to be between 90 and 120% of the design heat load. So that's the way things should be working. If people are manipulating those calculations to get bigger incentives and put in bigger systems, someone needs to know about that, honestly. That's not the way it's supposed to be working, and it's gonna not only use up the funds, but give people worse results. When you oversize the system, what happens is that it cycles on and off a lot more than it needs to, and your efficiency drops dramatically. So other than the person that's capturing the big incentive, really no one's winning in that scenario.
Another related question, that kind of implies that you have to seal up a home for energy efficiency purposes before you can do that calculation. Would you agree?
I think you need to evaluate the house and see where it stands. I'd say that probably, a good third of our housing stock is pretty much where it needs to be from an envelope perspective to be ready for cold climate heat pumps. Another third needs some targeted improvement, kind of the attic, air sealing, the rim joists that we were talking about. And then there's a third that is, the old farmhouses, the old leaky Victorians that need a lot more work to get them down into that level of air tightness where cold climate heat pumps are really going to make sense.
Right, and so both to that question and to the one before about how we might be able to influence the system, I would just encourage everyone on the call here to consider becoming a BPCA member, because if you want to make your voice heard, if we want to try to influence the program, so to speak, it helps to have a lot of voices, and that's part of what BPCA is all about. So just let me continue with some of the questions we've had. You talked about some of the kind of positions that are becoming available. What kind of training is required for these positions? Is it HVAC training? Is it on the job training? Is it a mixture? Just if you'd speak to that a little bit.
Yeah, so I'm part of a peer group of contractors, and one of the things we always talk about is how hard it is to find good people. Not only from a technical perspective, but people that show up ready to work every single day. I think a person that was eager to work and hardworking and had some basic general construction experience could very easily start as a helper and work their way up with on-the-job training. We are trying to offer some more options, kind of something in between, brief webinar series like we're offering here and a full 6-month trade school, something that would be almost like a boot camp to get people up and running. I think a big part of it also kind of depends on your learning style. I tend to be a person that likes to learn by books and YouTube and putting my hands on the tools and learning that way. Other people learn better in a more structured classroom type environment. Ultimately, there are kind of a well-defined set of skills that you need to get started as an installer, and a lot of those are kind of basic carpentry and site work, how to safely drill holes in houses, how to hang things from walls, plumbing level, and then some of it's basic wiring that this would all be done under supervision of a more experienced person. And then there's probably 20% of the job that is very specialized and involves refrigerant piping, handling refrigerants, and for that you really need to have an EPA certification, which is a class that you can take usually at very modest cost, and then a test that you have to pass. So that's kind of the path that would get you into a position as a helper that would allow you to progress. It's a much higher and more well-rounded set of skills that you need to become a service tech. That's actually a considerably larger knowledge base than an installer, and something that typically takes people years to move into.
Yes, exactly. But I will say that NYSERDA has a lot of money on the table now for on-the-job training. And if you can find a contractor that's willing to sponsor you, and I say this to those of you out there who might be interested in entering this industry, if you can find a contractor that's willing to sponsor you, there is money that can be put forth for that training, on-the-job training, and options are available. So feel free to reach out.
That's a great point, Conrad, is that participating NYSERDA contractors have access to this on-the-job training funds that in a lot of cases will pay half or more of the new hire's salary for a period of 6 months. And so it's a great way for employers to hire people at a low risk and have their costs subsidized during that period of their learning curve.
Yeah, exactly. It seems like maintenance could be a critical aspect of this work. Can you address the question of whether that is a separate career path or whether it's a gateway to this industry? What do you think, John?
Yeah. So I think a lot of smaller companies have techs that are both installers and service techs. And then once you get beyond a certain size and a certain number of jobs out there, that becomes very difficult to balance. There's kind of two separate pieces. There's preventive maintenance, which is something that is relatively easy to learn, and that's largely about cleaning and checking these systems, and that's something that early career tech can pick up pretty quickly. And then there's the whole troubleshooting piece, and that's something that requires a more experienced person. When a system goes down, it's giving you an error code. That's something that you typically would graduate into after being an installer and doing preventive maintenance for a while. Now, in all these cases, because of this labor shortage that we're dealing with, we're starting to think about what are some some ways that we could make best use of the highly skilled people. And one of those is, with all the technology we can have someone with a GoPro or a phone camera on site who can phone in their questions to a super tech who's back in an office who can provide technical support to multiple people out in the field. So I think this is evolving, and we're going to see, I think, more and more ways to plug entry-level people in a way that can help them succeed.
Very good. Yeah, I would agree with that. Can you differentiate a little bit for a couple minutes, just pontificate on the differentiation between air-to-water heat pumps as opposed to air source heat pumps that include distribution systems?
Sure. So everything that I was talking about today in terms of the ductless systems and the ducted air handlers, those are air-to-air heat pumps, meaning that our outdoor medium is outdoor air that's flowing through the outdoor unit, heat's being extracted, and then it's being transferred to indoor air through a fan coil. And right now, that's the dominant technology. Now, there is such a thing as an air-to-water heat pump. On the outside, it looks a lot like an air-to-air heat pump. You've got a compressor, you've got a fan, and it's moving air and pulling the heat out of that. But instead of cycling refrigerant into the house, it cycles water or water antifreeze solution. And that allows you to run that water through a radiant floor or through cast iron radiators. The temperatures that they generate are generally too low to use with a traditional baseboard system. Baseboard really works best at water temperatures of 160 or 180 degrees. Air-to-water heat pumps are typically producing more like 125 degree water, so they're ideal for low temperature systems like in-floor radiant, but they're not a good retrofit for baseboard systems in most cases.
So lifespan, one versus the other?
So all the parts of a air-to-air or an air-to-water heat pump, all the kind of game-ending parts that would fail are going to be in the outdoor unit. An air-to-water system is going to have a lot of the the smaller components that are similar to a boiler system, pumps, expansion tanks, maybe zone valves, things like that, which can be replaced without replacing the whole system. I suspect that their life expectancy is going to be pretty similar. We don't have a lot of track record with air to water in we're up here in Ithaca, we're in climate zone 6. I've heard that they are catching on more downstate where, you're might be in climate zone 4, and you can get by with some of those lower water temperatures and still meet the house's needs. It is a rapidly developing area, and I think, in a few years we'll know a whole lot more.
Very good. Another question, average cost of envelope improvement. I think probably if I were to answer that, I'd say $7,000. But if you add in an air source heat pump, might bump that up. What would you say, John?
Yeah, I'd say that envelope improvements could range from, almost nothing to, at the big end, if you're doing a lot of spray foam, or you're doing, dense packing all the walls in the house, that could be a $15,000 or $20,000 improvement. So, it's going to scale with the size and the condition of the house. A lot of the work scopes that we're doing are in the, the $3,000 to $8,000 range in terms of insulation.
Very good. So if you take your typical job, and again, I'm going to say $7,000 because I think that's what we've been using for years. And then you add on your air source heat pump installation, and you put a couple solar panels on the top to run the whole thing. Can you get out from under that for less than $25,000?
So I can't speak to the solar panel piece. Again, this is gonna scale with the size of the house and the heating needs and the condition and how much work it needs. And another big factor is going to be what incentives you're eligible for. If you do fall into either the Empower or the Assisted Home Performance Income bracket, it's entirely possible that everything but the solar could be free or pretty close to free. If you're in a higher income bracket, you're still going to be eligible for the utility incentives. So, we see end costs for the homeowner being anywhere from, $0 to, in some cases, $20,000 to $25,000. So there's just a huge range.
Yeah, and I know a lot of this is conjecture, and we have to kind of figure it out as we're going along. Let me ask you just one last question we have here about the transition from NYSERDA programs to utility programs. It seems complicated. Is it as complicated as all that? I mean, the utility programs seem less complicated, and yet they aren't providing as many incentives, it seems, and yet you don't have to provide as much evidence, so or at least as much quality control. So does this seem like a trajectory that is going to work in our favor here, or do you see this as something that's kind of is it a positive or a negative, John? The whole utility thing and how utilities are taking over these projects and kind of baking them into the distribution system.
Yeah. So the background for this is that from the launch of the heat pump program back in 2018 through April 2000, the heat pump incentives were administered through NYSERDA, and that was a very streamlined process. We submitted a brief application, documentation, and we got a check. Starting in April, they started to have the utilities administer those incentives, and so far it has not gone smoothly. My company, Stunk Planet, is owed, you know, a huge amount on those, and I know that other companies that are installing a lot of those are also finding that they've been slow to get their payments. They actually are requiring more documentation, not just a sizing calculation, but some follow-up forms. You know, not just the manual J, but the manual S, and in some cases the manual D, the duct design documents. So there's more, actually more paperwork, and so far very little money forthcoming. Not to be discouraging of anyone, I think that problem's going to be solved, and I think you know, our trade groups are actively talking to NYSERDA about resolving that, but we're in a little bit of a blip, and you know, everything is kind of weird now because of, you know, a lot of these changes happened in the midst of a pandemic, and we still haven't quite sorted it all out yet.
Yeah, so I'll just add to that yeah, you're absolutely right. It's a transition. Transitions are never easy when you're involving a bureaucracy, and NYSERDA is a bureaucracy, and the state of New York is a bureaucracy, and every utility has its own bureaucracy. And so, yes, there's going to be some bumps along the road, but as far as I'm concerned, it's a good time to invest in training, invest in preparation, move carefully and succinctly across this path. And so we're just about out of time. I want to thank you, John, for your time today. You did a great job. I would also like to thank everyone who's attended and encourage you to complete the pre-webinar survey if you haven't, and the post-webinar survey regardless, because that's how we determine whether we were effective and whether we have to shift and move forward in some different fashion. And then if you're interested in finding work in this industry, please reach out to us. We can hook you up with both training and jobs. And so I think, yeah, that's about our time is up. Thank you so much, John. Thanks everyone to attend. And any last words, John, before I sign you off?
No, just that we're going to be mailing out the slide deck and a couple articles to go along with this. And if you are interested in that hands-on training, please register for it, you know, as soon as you can.
Yeah, it's limited, so it's going to fill up fast, although we may do it again depending on demand. And so, yeah, I'm going to end this webinar, and I appreciate everyone. If you have any additional questions, feel free to email me.